Hey, welcome Algebra 2 students. We are going to do a small another unit. It is from a different book, so it's a little confusing because in the other book it is their chapter 12. So I'm going to try to refer to it as Unit 12 or simply the unit on sigma, series, etc. So let me pull up what I have sent you. And that would be this. Boom. Okay, so we're going to start by dealing with sequences. A sequence is a function where the domain is only going to be, they say positive integers. I have no objection to it being 0 or negative integers, but it is discrete. You don't have f of 1.2. You have f of 1, 2, 0, in my opinion, 100, anything like that. So given the sequence, f of n equals 1 over n squared, let's take a look at what those values are going to be. F of 1 is 1 over 1 squared, which of course is just 1. F of 2 is 1 over 2 squared, which is 1/4. F of 3 will be 1/9. F of 4 will be 1/16. And f of 5 should be 1/25. I have a perfectly good sequence. Write out the terms of the sequence, and those would be just 1, comma, 1/4, comma, 1/9, comma, 1/16, comma, and 1/25. And when we come around and ask part C, represent the sequence as a formula for its nth term, that's really where we started with. And again, so that is f of n equals 1 over n squared. Right back to where we started from there. Wrong computer, right computer. Here is another one, which we are going to write out and then graph. So in example 2, I've got a sub 1 equals n squared. 1 squared minus 1 over 2, that is 0 over 2, that is 0. A sub 2 should equal 2 squared minus 2 over 2, that is 1. A sub 3 equals 3 squared, 9 minus 3, that's 6 over 2, which is 3. A sub 4, 16 minus 4, 12 over 2, which is 6. And a sub 5 is going to be 25 minus 5 over 2, and so that is 10. If I were to graph this one, I start with 1 comma 0, I go on to 2 comma 1, I go on to 3 comma 3, I go on to 4 comma 6. The next one's presumably going to be off my chart, and I'm not going to connect these points because connecting them would imply that it has all the values in between, and it distinctly does not. Okay, write out the first 5 terms of this sequence, which is slightly interesting because of that negative 1 to the n minus 1 in there. So a sub 1 is negative 1 to the 1 minus 1 times 5 over 1. 1 minus 1 is 0. Anything to the 0th is 1. 5 divided by 1 is 5. I just get 5. My next one is negative 1 to the 2 minus 1. And now I have 5 over 2. If I do that all out, I get negative 5 halves. My next one without doing any work is going to be positive 5 thirds. And then I will go to negative 5 fourths, negative 5 fourths. And finally on to 1, although I'll continue the pattern and write it as 5/5. Okay. This is what I would call an alternating sequence. If I wanted it to start with a negative, instead of saying n-1, I could just say n. If I don't like that n-1 and still wanted it to start with a positive, I could say n+1 instead. Doesn't so much matter. There are very frequently infinite ways of doing the same thing. Okay, example 4, write out the first 5 terms of the sequence. It's always -1 if the n value is odd. So I've got a -1, a -1, and a -1. It's n squared if it's even. So 2 squared is 4, and 4 squared is 16. Those are my terms. Okay. As is often the case in math, we find ourselves going forward and going backwards. So as opposed to listing out the terms, now they listed out the terms, and it's up to us to find a formula for them. I will pause for a moment, or you should pause for a moment. I'll just write them down. Do try these on your own. So pause, do all these examples, and then unpause and see if we got the same thing. So at this point, you should be unpaused. For part A, I'm going to say we have n pi to the nth. For part B, it's visible, n pi to the nth. For part B, I'm going to say we have 2 to the nth. For part C, what do we have there? Okay. 1/3, 4/3, 9/3. Okay, so it's always something over 3, and we seem to be n squared over 3. And for part D, on the top row, we appear to have an n. On the bottom, we seem to have an e to the nth, but you might notice we are one of those alternating ones. So I'm going to throw in a -1 to the n. That would make my first one negative, so I'll do n+1. Okay. And that seems to be good. Okay. Moving right along. Factorial, definitely something that we saw when we did combinatorics. So I'm going to just fly through this. 0 factorial is defined as 1. 1 factorial is obviously 1. 6 factorial is 6 times 5 times 4 times 3 times 2, technically times 1. There's a 6 there. There's another 6 there. We have 36 times 20. We have 720. In part B, 3 factorial is 3 times 2 times 1. That is 6. So A, B, my answer is 6. C, 10 factorial over 9 factorial. Well, 10 factorial can recursively be written as 10 times 9 factorial. Over 9 factorial, those go away. I'm left with a 10. And D, you might recognize that as 6C2 or 6C3. It doesn't, no, it's not. No, it's not. Don't be silly. You might recognize that it looks something like things that we've done before, but it's not quite it. 6 factorial over 3 factorial, 2 factorial. I'm going to write as 6 times 5 times 4 times 3 factorial over 3 factorial. And 2 factorial is just 2. That goes away. That goes away. I'm going to turn this into a 3 and cross that out. 20 times 3, my answer is 60. Okay, continuing on. Write the terms of a sequence defined by a recursive formula. A recursive formula is one where they must tell you what the first step at least is, at least the first step, and then they tell you how to get to the next step from the previous step. So when I'm reading this, it says a sub 1 equals 1. So I'm going to put a 1 there. And it says my next one is 4 times my previous one. So I'm going to put a 4 there. 4 times the previous one would be 16. This would be 64. This would be 256. I don't know how high they wanted me to go. The first 5 terms, boom, we've got it. Recursive forms are really what you do when, and I'm going to pause this thing for a second. Really is what we do in spreadsheets a lot. So here I'm going to say 1 in this cell. I like to use 1 kind of in the middle. Now I'm going to say equals whatever came before me times 4. And if I copy that, I'm not copying 4, I'm copying those instructions. The instructions which say take whatever was there before and multiply by 4 and multiply by 4. And of course I can do a lot of them at a time and get not just the first 5 of them, but the first however many. Okay. Right, and back to, okay, back at it at example 8. Write down the first 5 terms of the sequence defined as following. They tell me my first one again. So my first one is 2. And my next one takes the previous one and divides it by n squared. I will admit that I do not call this completely recursive. I call this partially recursive because you need to know what step you are on. So my next term, so a sub 2 should equal a sub 1, which is 2 over 2 squared, over 2 squared. That is 2 over 4, that is 1/2. A sub 3 should equal 1/2 over 3 squared. That is 1/18. A sub 4 should equal 1/18 over 4 squared, and that is just a headache. Not too interested in doing that one or even the next one. Obviously, we can switch over to Excel, have it do it for us. Right. This next one is a little bit more complicated, since the recursive formula not only calls on the previous term, but it also calls on the term before that. They really needed to start me with 2 terms here. So let's see what we got. A sub 1 equals 2. A sub 2 equals 5. To find a sub 3, I'm making n equal to 3. It should equal a sub 3 minus 2. Oh, a sub 1 minus 3 of a sub 3 minus 1 of a sub 2. All right, so that equals 2 minus 3 of these 5s. 2 minus 15, it should equal negative 13. A sub 4, I will set up, won't actually do, should equal a sub 2 minus 3 of those a sub 3 things. Okay. And write down the first 6 terms of this one. I will let you do that on your own, and I imagine a lot of you guys will recognize it once you've got it all sorted out. If you don't, it is something called the Fibonacci sequence, which crops up in a bunch of different places. All right, and finally we have a actual word problem example. Wildlife Refuge currently has 100 deer in it. I'm going to say population sub 0 equals 100. They decide to add an additional 2 deer every month. They bring in 2 new deer, and it grows at 12% per year. So really 1% per month. So the population at the beginning of the next month should be 101% of this, which is 101 plus 2 more. So we're going to get 103 right there. And my population at the second month should be, and get a little dicey here, I'm going to take that 103, I'm going to multiply by 1.01, and I'm going to add 2. And now what I'm going to do, and I'm going to write that as 106.03-ish. Now, obviously, there aren't a 0.03, what we're doing, sheep, deer in there, but eventually that decimal point is going to come into play. So I'm going to say for my next one, I'm going to say answer times 1.01 plus 2. And the reason that I specifically wanted to do that was, so now I get that 109.09. I can just hit enter to get the next one, 112.18, and enter and enter and enter and enter and enter to get as many as I need. Okay, there you have it. I will see you for the next lesson. Stop that share, end this.